Today's lesson is about law of sine. Three types of triangles will be covered: AAS, ASA, and the ambiguous case SSA. Now for triangle ABC, we will say that angle A will face the side small a, angle C will face the side small c, and angle B will face the side small b. And the law of sine says sine A divided by small a equals sine B divided by small b equals sine C divided by small c. Let's take the first example, which is the case AAS. Now we notice that we have angle B and angle C are given in the question and the side C. Now to find angle A, you keep in mind that the sum of angles in a triangle is 180. And you do the following to discover that angle A is 45. Now, you remind yourself of the law of sine, which is sine A divided by A equals sine B divided by B equals sine C divided by C, and then you start selecting the ratios to find the rest of the question. Now we decided to find small a, thus we take this ratio, we do the cross product after substituting the values, and we will discover that A is basically sine 45 times 17 divided by sine 120. After doing the mathematical operation, you will receive the value of A. Now, after finding A, you have now the value of small a, the side A, and small c. Now you have to find the value of B. Thus you will repeat the same law of sine. You will apply the same ratios as in front of you. Okay, now we do the cross product. Thus we say that B is basically 17 times sine 15 divided by sine 120. You will continue solving and you will find the B values. Now pause your video and solve the following question. Now continue playing the video and check your answers. Now, we will go now in the coming example to the second case, which is angle, side between angle. Solve the following triangle. You will notice that angle A and angle B are given in the exam, and so the side between them, which is side C. Now to find angle C, we keep in mind the sum of angles in any triangle is 180. We do the mathematical operation and we discover that angle C is 70. Now we go back to the rule of sine or law of sine, and we will say sine A divided by A equals sine B divided by B equals sine C divided by C. I decided immediately to use sine A and sine C together. I'm substituting, aiming to find the value of A. You have to do this exactly, and you will find that A is 9.3. After finding A, you have to find B. Thus, you will keep repeating the same process by applying the law, doing the cross product, and then find the value of B. Now in the coming question, just pause your video and try to solve the question by yourself. Now compare your solution with the one in front of you. We will head to the last case, SSA, and it is side-side angle, not between, and it's the ambiguous case because it can deliver three results. Either you will have one triangle or two triangles or no triangle at all. Now let us start with the first example, which is no triangle case. Now basically we will drop an altitude or a height from the point C, and we will call it H. Now we will take this part of a triangle that consists of the H and C and A sides, and we will apply the sine rule to find the value of H. We know that when you drop a line, the angle will be always 90 degrees. Now we apply the sine rule and we will discover that H is around 12.22. And you need to notice that H in this case, 12.22, is actually greater than the length of CB, the side CB, or the side A12. And it means actually there is no way to create a triangle in this way. That triangle doesn't exist actually. Now we will take another example concerning the case SSB. We drop a perpendicular line from the point C. We call this line H, or the altitude. We take this part of the triangle and we apply the rule of sine. We keep in mind when you drop a perpendicular line, the angle will be 90 degrees, as you can see in front of you. By applying the sine rule, we will find the length of H. You can use the calculator by this point and you will discover that H equals 3.42. Now, when we notice that H, keep in mind 3.42, but the value of A, or the side CB, is 15, we notice that the side A equal 15 is much greater than 3.14, and 15 actually is not a number between H 3.42 and the side AC, which is 10. This is why you will discover in this case you will have only one triangle. Now, since you know that you have one triangle, because of the value of H 3.42, which is much younger than the value of A, you will take the triangle as it given in the exam and you will solve it normally. As it's a normal question, you will apply the sine rule to find the value of A, B, C, as you can see in front of you. We move to example number 3, and it's talking about also the SSB case. Here we drop the same vertical line from point B to the base AC, or the side little b or small b. We take this part again of this triangle, we apply the law of sine to find the height of H, or the altitude. You can use the calculator here. And when you apply it, you will discover that H equal 5, which is exactly the length of the side BC. It means you have only one case, thus you will proceed with this equation and solve it as before. Thus in this case, we have only one triangle. We'll move to the last example of the case SSA, and we do the same process. We drop a vertical line on the side AC to find what is the altitude or the height of this triangle. We take this part of this triangle, we apply the sine rule as it's shown in front of you to find H, and we will discover by calculating H that it will be around the value 9. Thus it is basically less than the side length BC 10 and less than the side length AP 14. We keep this in mind. Okay, now the fact that H equal 9, it is less, the length is less than the other two sides of the triangle. It means that we have two cases for the triangle. Now, first case, we take the question as it is given. We apply the sine rule. We find the side length A and the side length B, etc. We do what is requested from us. But we keep in mind, because the height of the triangle, the altitude, is less than the length of the two sides, it means there is another potential solution, another triangle. Okay, now we will highlight the second possible case of the triangle, and as you can see, it looks like this. And you need to notice that angle C in this case is an obtuse angle. Thus, we take the original angle C 64.14 that was found in the first part, we subtract it from 180, and we create a new triangle. In that new triangle, you have angle A and angle B and angle C illustrated as you can see them in front of you. Now, because you have a triangle that known with two sides and three angles, it is very easy to find the missing side. We are missing only the side B. Thus, we will apply the sine rule. You can use either side A, side C, angle C. It doesn't matter. You will use the ratios, you will use the rule, you will find the side B, and that's it. Thus, we keep in mind that if the altitude or the height of the triangle is less than the length of the two sides given, or of the length of the two sides given in the question, like you have a triangle with two known sides and the height is less than them, then keep in mind that in this case you have two triangles, two possible solutions. Okay, this is the end of the lesson. Thank you so much.